Now we will move to the next presentation that, as I promised, would be an input from the Future Cities Lab. This will be Chen Zong. She's a PhD student at the FCL with Professor Gerhard Schmidt, working on the simulation platform. She has, again, another background in computer engineering, some software integration and development of GIS. That's her background, so I think that makes it again interesting and hopefully a fresh topic to discuss later. The floor is yours.
Good afternoon, everyone. My name is Chen Zong. Actually, standing here is my honor, and also it's a challenge. And why I say it's a challenge? Because I look at the agenda of the discussion. There are three groups of people, one from Ethiopia, one from urban farmers, and then we're from Future Cities Laboratory, and myself is a computer engineer. I really think hardly to find a link between each other to make it a story. And I really try to find a hint from the last talk yesterday, digital technology and the sustainability. And I got answer from the presentation, the talk. Digital technology do not have a direct input on the space. Well, which means I can't find a link, can't find a connection. But that is the situation, that is current situation. What is the future? So I decided to do it in this way. And give you a presentation, tell you what we are doing, what information technology, what we are doing with urban design, and that you answer my question, tell me what's in the future. So I choose this topic about information. And about information is about piece of information architecture. It's a piece of information of the work in progress of our simulation platform in Future Cities Laboratory. And it's also a piece of information from Singapore. Sorry. I think I have 10 minutes, and now I think I have only 8. I make it in 2 parts. The first part is the work in progress of our simulation platform, and the second part is some questions for you. And I think now I'm going to use only 6 minutes to finish the first part, so really follow up. Yeah, the motivation of our simulation platform is to find new methods for better understanding of ever-growing urban data, and to make it available to the decision makers, the urban designers, urban planners. And with this motivation, we progressed last year both in research and service of our simulation platform. And this presentation is to give you an overview of the methodology, the work pipeline, and as well as some practical work we did, some selected work. Okay, there are different, of course, we only focus on data service at this time, not give you too much information. And we think there are different levels of data service. I made it 3, but actually it should not limit it to 3. We can give more, and you can also classify in different way. The basic level of data service is providing the raw data. It's not something new, which means you can download data directly from the GIS server, something like that. And this level, we keep the original number and the original amount of the data. It could be a massive data set. The numbers can tell you many things, but sometimes tell you nothing if you cannot understand the numbers. And if it happens, what's the solution? We go to the second level with data processing. We filter some noisy data and extract information from the data, make it more visible to the users. What's more we can do? We can integrate in knowledge to produce some new data out of it. And the knowledge is not just one domain, it's multi-domain. And with this, we can really do modeling and simulation to generate some virtual scenarios to support design decision making. And if it's 3 levels, if it's 3, I really cannot go back. Okay, if it is 3 levels of data service too abstract to you, we turn it another round. Let's say the pipeline. The pipeline of our data service. And of course, the first part is the pipeline is from data acquisition to data visualization. And at each stage, we can provide different data. And this stage is referring to a different level of data service. Of course, the first step is data acquisition. And the picture I choose just to show you a corner of the research in simulation platform. As I show you here, is that we can reconstruct the 3D buildings from the images taken by the flight, the UAV, by photogeometry. And after we got data, we transform it in another standard way, put it in a server, well organized in their structure, and the designers can easily access to the data and use it. And then we go to data modeling. As I show you here is an example. We put the building footprint and the average energy use and the master plan to give estimate energy consumption models for them. And of course, we have last part, data. Well, we really need data visualization. Oh. Can someone help me? Okay, visualization. And this is just one example, show you some spatial temporal visualization of the transportation data. We'll talk about it later. And this is just a pipeline. Maybe it's too general, so I'm going to give you some selected applications. Of course, I organize applications in the sequence of this data service. Then you can get a better idea of what we are doing. Next one. Okay, it works. Of course, we'll start from data acquisition. And Rocha is an area in Singapore. And it's a cooperation with different modules. Now you see how we simulation platform cooperate with the designers. And there are 3 groups. The first group is transforming and mining urban stocks. The second one is urban design and strategy and resources. The third one is our simulation platform. With different research focus and different research questions, we work together. Briefly speaking, this project is collecting data from Rocha area. But the challenge is how to address different data needs to answer multi-questions based on the same database. And you can see here, they really need different kind of data set. And what do we do to solve the problem? We decompose the data requirement to small piece. Let's say we provide different level of details of the data. And you can see here, we collecting data manually, but with iPad, and then the data will automatically transform into a database, really with parameters and small components, and we combine with combination of different parameters and components, we can provide different levels of data details. And after the collecting data, we go to next case study. Here we go to data acquisition and processing. And this, compared to the first one, this one is more automatic. It's easier. What you have to do is just to install this little software which is developed by ourselves with your smartphone. And when you're traveling in the cities, we will automatically transfer your data to the server, and the server will automatically process your data to detect by the acceleration. It can tell you the transport mode. You are working or by bus or by car. And of course, if you use different transportation, you have different CO2 emission, the energy patterns. And the mapping on the map, you can say you are moving at different locations, have different patterns, and you have different contributions, I mean CO2 contributions to our city. And this is a real case study happened in Singapore this March. Someone with his smartphone is traveling in Singapore, different places testing of our application. Then we go to the third one, to the data analysis. What's more we can do with the transport data? We transformat the data into the shape file and make it in and do kinds of analysis. As you can see here is the trajectory and time information, as well as the most active mobility in Singapore, some classify the trips and the buffering of the distribution. And here is a special interaction models to see the interaction between different planning areas. And then we're mapping the different urban activities, not just by locations, but also by time. And then we got kind of visual analytic tools. You can choose different size of the cube. You see where is the most dense area during the time of the day. And you can know where is the most dense area, where is the most diverse area of activities. And then I put everything together. Here is all the research work, but I select some beautiful pictures. Here is our simulation platform. And maybe I should check the time. I think it's less than 8 minutes. I give you the information of a methodology, a pipeline, 3 applications, and PhD research work of the 15 PhD work. What's your feeling now? Is that too much information? Which you can't really follow up and you can't remember? I think it's too much information, right? Yes, that's why we need simulation platform to handle the information, to handle the massive data. Yeah. And now I'll let you have a break from the virtual city, from the digital technology back to our real world. This is Singapore. Yeah, there is some natural things in Singapore. And then this break will not take too long. We go to the last part, the conclusion. And this is also my question. I don't know if you still remember what I mentioned at the beginning and also our motivations to find a better method to help to get a better understanding of the urban space, which means digital technology do not have a direct impact on the space. But my question comes, how can we get a direct impact on the space? What's more we can do about information technology, digital technology? How we can change the future world? And who will make the future cities? Only designers, or we can also do something to have a direct impact on it. And I hope we can find some answer from the discussion and also from you. And thank you for your attention.